All right, let's work on the substitution rule. So to understand the substitution rule, we firstly need to understand what it solves and why we need it. So let's consider this. We can already integrate functions such as the following. So you can integrate 5x to the minus 7. You can integrate sine x. You go to your trig tables and the derivatives. And you can even integrate secant x and tangent x. Okay, that's great. But ask yourself, can you readily integrate functions such as this? So 5x times 4x squared minus 9, and then that is raised to the power minus 3. Can you integrate that? Okay, think about it. Try it, okay, and check if you can. Or what about sine x times cosine x to the power 7? Can you integrate this? Right, so just take a minute to consider that. There are no trig tables where you have the original trigonometric function and the respective derivatives for this here. Okay, so you can't really integrate that with your current knowledge. So the above examples, and I'm talking about these two, illustrate that we require an additional technique for integrating these functions here, functions like this. And enter the substitution rule. The substitution rule is useful when we have a function of the form. Okay, so this is what we're going to have. We're going to have f of g of x, and then that is going to be multiplied by the derivative of g of x. So just a couple of things I want you to take note of and what I'm going to say in these examples. This g of x, okay, I call that the inner function. Okay, so you're going to have g of x, and I call it the inner function because you are applying it, or you are inserting this inner function into another function f. Okay, so that's why I call it the inner function. And then you're going to be multiplying this entire f of g of x by g prime of x, the derivative of the inner. So when you have a function that is of the form f of g of x times by g prime of x, then you need to use the substitution rule. And I know right now this thing looks very intimidating, but once you begin identifying it and applying the techniques that I'm going to show you, it's going to become super easy to identify when you need to use the substitution rule. So let's go through some basic examples on identification firstly, and then we'll use the substitution rule. Okay, so I want you to determine if this function here is of the form f of g of x times by g prime of x. So take a minute and try it. Okay, let's handle this one. So the key thing, this is what you need to identify. The key thing to identify if a function is of this form is to identify firstly the inner function. Now the inner function is usually a function that is encapsulated or enclosed within brackets. For example, in this case, we have the inner function 3x squared, that's in brackets and it's being raised to the power minus 5. Okay, so the inner function is usually inside brackets and it's raised to some power, or it's the argument for a trigonometric function. What I mean by that is if I had, for example, let's say 3x and I had sine of 3x squared, okay, this here, since it's the argument of my trigonometric function, or in other words, it's still in brackets, okay, this I would suspect to be my inner function. In most cases, it's going to be my inner function. So the first step is to identify what your inner function is, the g of x. And in this example here that I've given you, the g of x is going to be 3x squared. Okay, so it's 3x squared. The next thing that you need to do is find out or calculate the derivative of your inner function. Okay, and sometimes in most examples you can do that mentally. So let's get the derivative of my inner function, and that is going to be 6x, right? So first thing, we identified the inner, then I got the derivative of the inner. The last step that I need to do is identify my outer function. And my outer function is that g prime of x. It's the one that's just being multiplied by f of g of x. Okay, it's the one on the outside. You can see it's not really enclosed within brackets. Okay, it's just on the outside, nothing's really happening to it. So here it is, 3x. Then what you need to do as part of this last step is take your outer function and divide it by the derivative of your inner that you calculated. Okay, if you get a constant number like 2 or 3 or -4 or half, okay, anything that does not involve the variable you're dealing with, okay, then it is going to be of this form. If it's of that form, it means you can use the substitution rule. So when you perform that last step and you get a constant number, okay, that does not involve the x variable, then yes, you can use the substitution rule. Basically, it means that you have something of this form. So let's do it for this example. Okay, we almost completed it. So my inner function is 3x squared. That's the first step. Next step is to get its derivative of the inner, so it's 6x. Then what I'm going to do, identify my outer function, 3x, and I'm going to divide it by 6x. So 3x over 6x, the x's cancel off. This is equal to 3 over 6, which is a half. Is this a constant number that does not involve a variable? Yes, it is. Okay, it's half, and that's what we want. So yes, the answer to this question is yes. This function here is of the form f of g of x times g prime of x. Hence, you would be able to use the substitution rule to integrate that. Okay, to integrate it. Just another note that I want to make in case you are wondering. You might have seen that we have g of x and g prime of x. And you may be saying, hang on, when I differentiate 3x squared, it's 6x. Okay, what's the deal there? It's 6x. It's not, so this is g prime of x, right? That's g prime of x. But isn't this g prime of x? So aren't these two supposed to match? Shouldn't this be 6x or that be 3x? What's the problem there? Why aren't they matching? Absolutely, I agree with you. But, okay, but they do not have to match, okay? They do not have to match because what we could assume is that this outer function is actually 6x and there is a half in front of it. Okay, there is a half in front of it, so half times 6 will still give us 3x, and we could be considering this portion here. So we could be just considering this portion here, in which case the 6x would match with the 6x. This is the constant that we got when we divided the 3x by the 6x. So we can manipulate the original function such that it matches that form exactly and we get g prime x exactly. But the truth is it doesn't matter when we are going to perform the substitution rule. Okay, you can think of this as an invisible constant if you want to. The effect of this constant doesn't really affect the substitution rule or using it. So these two, okay, the 3x and the derivative 6x squared don't have to match exactly. They must just be a multiple of each other, which is why we got a half. Okay, so they don't have to match exactly. All right, let's try exercise 2. So just identify if it is of the form f of g of x times by g prime of x. All right, let's handle this one. So I'm going to rewrite this in a better form. So we have 5x squared minus x, and notice that this is in brackets, right? Now I agree with you, yes, it's in brackets, but you need to ask yourself, is anything being done to these brackets? Is it being raised to the power -2 or -3, or is it tangent of these brackets? Is any outer function being applied to these brackets? And the answer is no. So this should give you a hint that yes, although these are in brackets, nothing's actually happening to it. They're just in brackets, so it makes our work look neat, basically. So this is not going to be our inner function. Let's take a look at the next term. So the next term is square root of that thing inside. I can write a square root as to the power, I can write it as to the power half. So it will be 10 over 3 x cubed minus x squared to the power half. Now take a look at this term here. Yes, it's in brackets, and some outer function, no, it's not outer function, some additional function, and that's the f function, is being applied to it. This function here on the inside is being raised to the power half. So this is a clue, and it tells us that this portion here that I've just squared out in blue, that's my inner function. So let's make this neat. I'm going to circle my inner function. That is my inner function. Now I'm going to get its derivative. So its derivative, you take the derivative of that, it would be 10x squared minus 2x. And what I'm going to do now is I'm going to take my outer function and divide it by the derivative of the inner. So let's check what we would get. So we'll take 5x squared minus x divided by 10x squared minus 2x. Now, it doesn't look like these two can divide immediately, but there's something peculiar about the denominator. Let's pull out a common factor of 2. Yeah, let's pull out a common factor of 2. Okay, so we'll get 2 into 5x squared minus x. And now this term cancels off with that term. We are left with a half. We are left with a half that does not involve any variable at all, any x variable in this case. Therefore, this function is of the form f of g of x times by g prime of x. Hence, we could use the substitution rule to integrate this function. Okay, again, I want to stress, this is my outer function. Okay, this is the derivative of the inner, that's g prime of x. The outer function does not have to match exactly with the derivative of the inner function, the 10x squared minus 2x. It just has to be a multiple of the derivative of the inner. Because like I said in the previous example, we can always manipulate the function that they give us, okay, to get it into a form where the outer function matches the inner exactly. But we don't need to do that. That's just extra work, and we are going to get to the same answer eventually. Right, so that's what we have here. The answer to this question is yes, it is of this form.